Okay, welcome everybody to another Motec webinar. My name's Pete Swinney and today's subject is how to test ECU outputs. Get the last few people into the room. Okay, so this is an extremely useful feature that our M800 series of ECUs and in fact our earlier M4 and 48 ECUs do. What it does is allows you to test the controlled devices that the ECU control over. So these are things like injectors and boost control solenoids and relays and things like that. So it's an extremely useful feature, and this webinar will take you through the process of how to do that. All right, some of the topics we're going to talk about. We're going to talk about when to test, when would you use this feature, some of the precautions conducting the testing. Also, the test sequence, the order in which you go through the devices, and a little tip on perhaps why sometimes things won't work. All right, when would you use this feature? The most common time would be when you've just wired up a new setup. The injectors, the coils, solenoids, relays, boost control devices all get wired to the ECU via wiring, and they need to be into the correct inputs in the ECU and calibrated correctly. And it's kind of nice when you're wiring a car to be or an engine to be able to turn the key and have the thing start straight away. So one of the first things to check is that you've actually physically wired everything up. Now on the view screen we can check that our sensors are connected correctly, and we can operate throttle positions, air temperatures and things like that and watch it on the screen. But we can't really see if our coils are going to fire in the right order or our injectors are wired up correctly. So using this feature we can go through that process and check that each injector is wired where we think it is, and that it's all going to work correctly rather than up and bang and fire flames out the intake. So good process. The other time that I'll often use the output test is if you are maybe at a race meeting or out doing some testing and you find that something's not working right. Maybe the boost boost control doesn't appear to be working right. Maybe there's a misfire problem. So I'll often go back to the basics and make sure, first of all, that the boost control solenoid is actually operating. Check that it's operating. We simply come into this section of the software and pulse the solenoid, and we'll have a listen and make sure it's going properly. Same with ignition. We'll often potentially test coils by forming a gap across a large gap spark plug and going across each coil and looking to see if there's a weaker spark. Sometimes we'll extend that gap out towards an inch, and we might find on a 6-cylinder engine that the 5 coils will jump 1 inch gap easily, but one of the other coils may have a really weak spark that we can see, and that leads us to looking at either that ignition lead or that coil or that spark plug, and lets us kind of narrow down the search on what the problem might be. So again, a useful feature. So some precautions before we get started. We are going to be checking spark visually some of the time. So the last thing we want is leftover fuel sitting in the manifold and you to have a spark plug lying on the manifold spark. We don't want to see people's eyebrows burned and cars being melted to the ground. So be careful about that. When we're testing injectors, it's probably ideal not to have the fuel pump operating when that happens. So disconnect the fuel pump via its relay or the fuse. And as tempting as it might be to have your cheeky apprentice hang on to the end of the coil to test if firing. These days, that'll sort of lives rather dramatically, so we need to be careful that when we're connecting or placing spark plugs to test for a spark, that these are well away from people, that we're letting people know that we're going to conduct this type of testing. This is especially true when you're going in and out of the test screen. Often the ECU will cycle, and if you've got people around helping you with the testing, we don't need them to be refitting coils or something like that when you move in and out of the software, because often you will get an ECU cycle which will potentially fire one coil. So it's a good way to eliminate your friends when you're doing that kind of stuff all wrong. So let's try and avoid that. All right, probably the primary thing to do before you even get started on this is to make sure that the firing order is entered in the ECU software. So, assuming that you know how to get online and to the manager, see the menu tree here. We're going down to adjust, general setup, firing order, and in this table you enter the correct firing order for the engine you are working on. Now, you don't need to enter this to make the engine work. So often you'll get to this table on a running engine and there's all zeros in there. This does not tell the engine which coil or which injector to fire on that subject. And when you wire in, let's say a V8, which we have in this case, wire in 8 injectors, wire the injectors in the firing order. So number 1 will be the first injector always, but the injector 2 on the ECU will be the second injector to fire in the firing order. So in this case down here, I'll just point on the second fire here is cylinder 8. So you need to wire the injector that is on cylinder 8 to injector number 2 input in the ECU. The next injector to fire will be the third injector 3, and in this case here that will be cylinder 4. So you need to get the injector at cylinder 4 and wire that in injector 3 input of the ECU. So this firing order does not determine the firing order of the injectors coming out of the ECU or the injector drives on the ECU. It simply labels the software for the cylinder tables and for this ECU output testing. You'll see a bit more of that shortly. All right, to get to the test output area, we actually need to go out of the ECU manager or out of the online side as far as being inside the ECU calibration area, and you go to utilities and down to test outputs. And once you do that, you'll be presented with a screen like this. So the test sequence that we should conduct our testing in is to do ignition first, then injectors, and then your auxiliary outputs. Now, the reason we do ignition first is that if we were to do the injectors first, often people have fuel pressure still in the rails, even though they may have the pump disconnected. And during the testing of injectors, we end up with fuel in the cylinders. Now, sometimes maybe the person is disturbed, sometimes maybe wound over, and it's potentially possible for you to end up with fuel in the exhaust system. Now, if we have that situation occur and then we test the ignition, find yourself in a situation where you're creating a rather large explosion, not only in the combustion chamber, but in an ideal world, we'd like you to test the ignition first. Before we actually test the ignition itself, we need to do one small check. Now, this is very rare for it to be anything other than our normal standard test, but I'd like you to go back into the ECU software and determine the ignition type. Now, what I mean by that, go back into through the main menu and down to general setup, ignition, and the setup, you'll see the ignition type. Now, I'm not going to get into the details of what number to enter here. I'd assume that you will have the correct number installed, and that number will either be 1 or 2. Now, number 1 is what you will find is for common, almost all engines that you'll find, and I'm going to say about 95% of engines that will be a number 1 style ignition level. And basically, just very briefly, that is a falling edge trigger. What that means is that the coils are turned on, the dwell period of the coils are turned on when the voltage is high and turned off when the voltage falls down to ground. Now, there are a very few possibilities. MSD CDIs made by the company MSD in the USA use a rising edge trigger. Some early Hondas use a rising edge trigger, and the odd BMW uses a rising edge trigger. Now, that will have, if correctly entered, correctly calibrated in the software, would have a number 2 for a rising edge trigger. And again, briefly, what that means is that the ECU or the coil and module turn on when the voltage is low and off when the voltage is high. So it's a reverse polarity style setup. What we need to understand is which number is in this setup so we can change our ignition test regime to match. Okay, so now we go back to our auxiliary output testing, and we find already laid out here under the ignition screen, and in this case we have a V8 with wasted spark coils. So 4 ignition outputs are being used, and cylinder 1 and 6 have wasted spark coil. Cylinders 8 and 5, cylinders 4 and 7, 3 and 2 are firing together. Now, in the setup, if ignition type was 1, which is what I'm going to suggest 95% of you will have in your setups, then these setup parameters here you leave as they are. Okay. If you're in the minority and you do find that the ignition type is 2, that is the correct setting for your engine, then you need to set up your parameters here. So the duty cycle needs to be around 96 and the dwell at 48 milliseconds. Now the dwell in reality isn't 48 milliseconds. It's simply the fact that the test regime in the auxiliary outputs test does not change its polarity linked to the setup in the ignition setup screen. So we need to manually change the way the testing is done by changing the duty cycle here. Now you can do that if you want by using these up and down arrows to change that duty cycle from the 4% to the 96%. You'll note here that to start the test we push the start test button, and it's at this point we need to be very careful that there's no one holding on or anywhere near the coils that you are testing. Okay, so after pushing that start test button, you will see here that the little radio button went from red to green, and at this point we can choose which of the coils that we are testing. So in this case we have the ignition 1, and that should be coils 1 and 6 firing. So in this particular engine it had a set of LS1 coils on it, so it has 8 individual coils that are wired in waste spark fashion. So we should have coils 1 and 6, if everything is wired correctly, firing. Now the way to set this up to do it safely is that you should have removed spark plugs or another set of spark plugs and place each spark plug in the end of each lead. ignition lead, and the spark plug should all be earthed. So each spark plug can be viewed to see if it's operating correctly. Now, sometimes you can hear coils firing, and so I've seen some people simply listen at each coil for coil event, firing event happening. Okay, and you can go through and click on each radio button and check that each coil is wired correctly. So assuming that that test passed with no problems, you would then move to testing your injectors. So again, ensure that your fuel pump is off and everything is safe. You don't have the chance of any fuel leakages. And you'd start at number 1 and simply click the number 1 radio button and then start the test. Sometimes people get confused as to which injector is running, especially on V8s with big aluminium fuel rails. You can listen to the injector and think that that's running, but often the sound of a neighboring injector or an injector that's close by, can echo down the fuel rail and make it sound like number 1 is firing when it's actually not. So some of the methods that you could use to determine that the injector is actually running is to use the screwdriver up to your ear, like a stethoscope, or even if it's easy, remove all injector connectors and then just connect the one injector that you are testing. Hear the sound of it operating. You can actually go and click down even with the test staying running. So with the start button pushed, you can actually run down and click each injector and just go through and test that they're all working quite quickly. Another useful feature that you can use this for is you can actually flow injectors using this feature. So we can actually flow injectors at a certain pulse width. We can dial that pulse width up here with these little arrows, and I can run this engine or run this test at a particular RPM and a particular pulse width for say 30 seconds, and I can wire that up so that I've onto an injector that's held over a test burette, measure the amount of fuel coming out on a test rig. So it's quite useful for that. Moving on to the next test, you have your auxiliary outputs. Now, in this example here, we have drive-by-wire configured. So this engine, we can't test the drive-by-wire motor with this method. There are other ways of doing that. So the first 2 outputs you can't test, but you can go through and check each output after that. So with the auxiliary 3 radio button checked and our test started, we should hear the boost control solenoid clattering away. If it isn't making a noise, we need to see if we've wired it correctly, if there's power on the solenoid, or what our problem is. And you can go through the rest of them and click each button and make sure each device operates. Warning lights come on, air conditioning clutch engages, fuel pump operates, fan operates, everything working correctly. Sometimes if people have been playing and the duty cycle is very low here, sometimes a relay may not operate. So maybe your air conditioning clutch relay, if this duty cycle here is somehow someone's dialed that way down to 1%, then that's not enough to pull that relay in. In that case, you need to make sure that the duty is up at 20, maybe even 50%. You can adjust that there. You can then go across to your other spare auxiliary outputs. In this case, our next available outputs are on the ignition. There are 2 spare ignition outputs, and in this case we have an auxiliary table which is connected to a spare set of injectors for this particular engine, and so we can check that those injectors are operating. Could be a relay driving some injectors, could be a cam switching, relay switching some cams on say an early Nissan. And on our 6th ignition spare auxiliary output, we have spray bars configured to see that they're working as well. If you have one of our our E888 expanders wired in on the CAN bus, and you click on this tab up here, you'll also see its auxiliary outputs available for testing as well. Okay, a couple of reasons why potentially things may not work. The most common is power supply. Now, if you've been very diligent and wired your 800, 400, 600 up the way we suggest, your actual auxiliary output testing probably won't work. The reason for that is that especially the ignition system, over on our wiring diagram, you'll see that the ignition system has its power supplied via a relay, and that relay is triggered. I'll tell you how to trigger it here on note 3. What we suggest is the idea is that the ignition system relay should be activated using the fuel pump control wire. So the fuel pump control wire normally turns the fuel pump on for 2 or 3 seconds on the on event, and then only turns it back on when it detects RPM. So if you're sitting there with the key on, then the ignition system relay, potentially, if it's wired in this manner, will not have any power. So you have a number of options. One obviously is to ground the wire that triggers the relay, and that will turn the relay on and therefore supply power to the ignition system. Or you can remove the relay and bridge the relay with a simple jumper wire. Obviously, you'll need to know how your system is wired if you're looking to cure that problem. Same could apply for the injectors, and again the same could apply for, say, a boost control solenoid that's not working. Maybe the power is coming from a relay that's not on, or maybe the power's not there at all. Another couple of devices that don't actually work on individual cylinder testing like this, and that's the CDI8 and our ignition expander work on coded signals coming from the ECU. So we can run 8 coils from a CDI8, but it only uses one ignition output to do it, and it sends like a coded signal to do that. That doesn't actually work with our auxiliary output testing. And likewise for the ignition expander. I'm just going to go back and reinforce the whole firing order thing back here on injectors. Now, when we put the firing order in, and you can see that firing order turning up here, cylinder 1, cylinder 8, cylinder 4, I assume you'll have picked up on that. But you can see here, if you don't put the firing order in here, we'll just get injector 1 as cylinder 1, injector 2 as cylinder 2. So for this reason, you must put the firing order in the software in order to have it laid out here so you know it's wired correctly. So basically, that concludes the webinar. It's a relatively simple test to do, the testing of our outputs. Hope you found this interesting. More information on our webinars can be found at our website. And any questions you can ask on our forum. If anyone's got questions today, you just pop them up in the chat box, and I'll hang around for a minute or two and see if I can answer those directly. This webinar will be up on the website within an hour or so, all going well, and we hope you tune in for another one soon. Thank you for attending.